Morning guys, so last lesson we did some Sokotoa questions and Pythagoras questions that were just a bit more unusual. Today we're going to do Pythagoras questions that involve algebra as well. So there's going to be a lot going on in these questions. Everything in here you're capable of doing, it just will look that bit more complicated and you may need to rewatch the video just to understand it, which is why I put it in as this last lesson before we go back to normal school lessons, so that you've got the chance, if need be, to go back and rewatch the video so that you can understand what's going on. Right, but like I say, there will be a lot of steps. Don't give up straight away. So we've got find the length of the perimeter. So we know perimeter is the outside of our shape. So if I was going to come up with an expression, I would say the perimeter was equal to, and I'd just add up everything around the outside. So 3 add 6 is 9, add 4 is 13. So I'd have 13x plus 22. Okay, but they haven't asked us for an expression, they've asked for the actual perimeter. So we're going to come back to this later on, once we actually know what our x value is, to be able to tell us the perimeter. So if we think about it, instead, if I'm going to work out what x is, I need something that's the same in both of my shapes. Okay, now what I have got is I've got this side here is a matching side for both shapes. So we're essentially going to do Pythagoras for this shape and Pythagoras for this shape to get an expression for this length. That way I can put this one and this one equal to each other and actually work out what x is. So I'm just going to label them shape A and shape B, just so that as I'm describing you can hopefully follow it a little bit clearer with what I'm doing. So if I look at shape A, if I was going to do Pythagoras, it's a shorter side. So we know for a shorter side what we're going to do is we're going to do the longest side squared, and I'm going to subtract the shorter side squared. Okay, now what we then do is we then square root it. So we're going to do it all in one step. Okay, now that's going to give me the shorter side on this triangle. I'm just going to do this because I know I'm going to run out of space. Okay, so I'm just going to tidy this up a little bit. So if I do 22 squared, I've got 484. So this I can say is the square root of 484. And just be careful, I've put brackets around it to say that all of this is squared. So 3 squared is going to give me 9. X squared is obviously 9x squared. So that is my expression for that length there. Okay, if I use shape A. If I now look at shape B and do exactly the same, I've got the longest side squared, subtract the shorter side squared, and then square root. So square the sides, subtract them, square root it. So I've just done it in one step. This I'm going to tidy up a little bit. Now this is going to give me 36x squared. This is going to give me 16x squared. So if I do 36x squared, take away 16x squared, I'm actually left with 20x squared. Okay, now remember what I said. Both of these are describing this length here. So they're both telling you exactly the same thing. So although it looks horrendously complicated, I can just say that the square root of 484 minus 9x squared has to be equal to the square root of 20x squared. Now if the square root of something equals the square root of something, I can just essentially cancel out the square roots by squaring both sides. I'd end up with everything that's inside my square roots equaling each other, because they obviously have to give me the same value. From there it becomes nice and easy to solve. We add 9x squared, I'd get 484 is equal to 9x squared. Then I'm going to divide by 9, just because that's not going to give me a nice number. I'm going to leave it over 9. And then we know the opposite of squaring a number is to square root. So I get a length for x as 484 over 9, square root the answer. I get 7. Oh, that was 29. Sorry, there's always something you do wrong. Try that again. 484 divided by 29 and then square root it gives me an answer of 4.09 centimeters. So I've now got my value of x. But remember, with these sorts of questions, there's a lot going on. Always go back and check you've answered the question. We wanted the length of the perimeter. I found out what x equals. So remember, we come up with an expression for the perimeter at the beginning. So I've got 13 times my x value plus 22. So rather than use the rounded number, I'm actually going to use my calculator's value. So 13 times the answer, and then I'm going to add 22. I get a perimeter of 75.1 centimeters. Okay, so there's a lot going on there, but keep remembering it is just Pythagoras, just like you've seen before. Okay, and you have got the video to keep coming back and watching it again. You may want to have a go at the similar question to that that's on the worksheet first before you listen to the next one. Choice is up to you. Right, if we look at the second one, we want to find the value of x. Now, again, I've just got a right angle triangle, so I'm just going to use Pythagoras. I know that the square of this side plus the square of this side has to equal the square of this side. Okay, because that is Pythagoras. A squared plus b squared equals c squared. So I know 3x plus 10 all squared plus 2x all squared has to equal 55 squared. Okay, now 3x plus 10 all squared, remember, is 3x plus 10 multiplied by 3x plus 10. So it's you expanding a double set of brackets. Okay, now you can expand the brackets however you like, but using grid or using foil is what I mean. And you'll end up with 9x squared, 30, 60x, and 100. If I expand this one, I'd end up with 4x squared equals, and then 55 squared is going to give us 3025. So tidying this up a bit, I get 13x squared plus 60x. And remember, because I'm aiming to get a quadratic that I can solve, I need to bring this 3025 across. So I'm going to subtract 3025 from 100. I end up with minus 2925. Okay, so I've now got a quadratic that I can solve. It is a particularly horrible quadratic. Okay, best thing you can do is use the quadratic formula. Don't worry about trying to factorise and solve something like this. The likelihood is it's not going to factorise. Okay, there never tend to be questions that are going to give you relatively nice numbers. So quadratic formula, we've got minus b plus or minus the square root of b squared minus 4ac all over 2a, and I get an x value of 12.9 centimeters. Just to check, remember quadratics always give you two values, so we're going to go back and change that plus for a minus. I end up with a negative value, and since this is just 2x, I can't have a negative length, so the other one we just don't use. And that's it. X equals 12.9 centimeters. Okay, so that one hopefully a little bit more straightforward than the other ones the last one we saw. Right, we're now going to have got this one. I've got a feeling I might need more paper. Right, so question 3. Now this is 3D Pythagoras, which you did last lesson. Okay, and now it's just in terms of x's as well, so it makes that a little bit trickier. Okay, so we've got find the length of the interior the length of the interior diagonal is 56 centimeters. We want to find the volume of the cuboid. So we know, first of all, if you were asked to find the volume of a cuboid, you just multiply the three lengths together. So 2x times by 5x times by 3x. So we know the volume is 2 times 5 is 10, 10 times 3 is 30. So I know the volume is 30x cubed. I just need to know what x is first of all. So when it talks about the interior diagonal, that means, bear with me, let's find a ruler. We're going, interior diagonal is from the top corner to the bottom. Okay, so I know that length there is 56 centimeters. So that means to create my triangle, I also need to join that diagonal up.